Now I want to continue, and we're going to expand on this idea. So we've talked about what concentration is and how to actually calculate a solution's concentration, but you know very well that concentrations can change. If I take that really concentrated lemonade and I add more water to it, it is no longer going to be the same concentration, right? And there is a way for us, of course, because chemistry loves calculations, there's a way for us to calculate that change. Now, there's two ways that you'll see this formula. The first one is this: M1 V1 equals M2 V2. And what this stands for is the molarity of the first solution times the volume of the first solution is equal to the molarity of the final solution times the volume of the final solution. Sometimes you'll also see it written, and it's exactly the same thing, but they use C instead of M for concentration, and also C1 V1 equals C2 V2, okay? And that's exactly the same formula. I'll be using the M1 V1. Why? Because that's what Mr. Huber made me use. Either works just fine. And what this does, or the reason that this works, guys, is if I multiply my volume and my concentration in molarities, I will get moles. All right, I'll just end up with moles. And if I'm not adding more solvent or taking solvent out, the moles I start with better equal the moles that I end with. Okay? So that's why this formula works, is I'm not changing the number of moles, I'm just changing the volume. And if I change the volume, I'm going to change the concentration. So let's do an example. Let's say that we have a 10 molar solution of NaCl, and we have 0.5 liters of that solution, and we're going to add another 0.5 liters of water. Okay, we're just going to add more solvent. Okay, so the way I would set this up, I have my formula, and I know from reading it, this question, that my M1 is 10.0 molar, and I'm going to just say molar because I'm not changing solutes. And my initial volume, my first volume, is this 0.5 liters. Okay, so I got that right here from the first part of my problem. And then I am looking and I say, okay, my final or my second concentration, I don't know. That's what they're asking me to find. So I'll just put a question mark there. And then my second volume, well, I started with 0.5 liters and then I added 0.5 liters. So that second volume ends up being 1.0 liters. All right, so if I go back to my formula, I know M1, V1, and V2, right? So I know M1, V1, and V2. I am trying to figure out, in this case, M2. So what I like to do is rearrange that formula to get M2 equals M1 V1 over V2. I just divided both sides of my formula right here. Divided both sides by V2, right, to get my formula of M2 equals. And then I put my numbers in. So I got 10 molar on top multiplied by my 0.5 liters, divide that by my 1.0 liters, and notice my liters units to cancel, and my concentration that is left is 5.0 molar NaCl, right? Which should make sense, right? If I've diluted it by, I doubled my volume, I should be having my concentration if I haven't changed the moles. Now, what's really important here, guys, definitely pay attention to this. Please pay attention to this. That for my formula, or for this formula to work, my concentration units were the same for M1 and M2, and my volume units were the same for V1 and V2. You cannot use this formula if you do not have the same units. So units, units, units matter, okay? Don't ignore those. Do not ignore those. All right. All right, so hopefully you were able to do those problems in the Ed puzzle. But I want to continue going on. I want you to go ahead, pause the video, and try these calculations. It'll be on the Ed puzzle. Okay, hopefully you were able to do that. Let's go ahead and work through just a little bit. If I've got here, for this first question, here is a volume, right? There's a concentration, so here's a V1, here's an M1, and there is my V2. So if I do that first guy right here, M1 is 1.6 molar, V1 is 175 milliliters. I'm trying to find M2, right? And the V2 is 1.0 liters. Notice units are different, so I have to modify. I'm going to change this V1 into liters, and so doing my appropriate conversion, V1 becomes 0.175 liters, because remember, there are 1,000 milliliters in a liter. And so then doing that, I'm going to use that same formula I just did in the last slide. M2 is going to equal to my M1, which is that 1.6 molar, times my V1, which is 0.175 liters, divided by my V2, which is the 1.0 liters. Crossing those off, we get M2 is equal to 0.28 molar, and that's lithium chloride. Okay. And taking a look at the second one, the M1, we don't know, right? We need to make our final thing we need to make. Let me change colors here. Yeah, there we go. So the final thing we need to make is 10 liters of this 1.2 molar KNO3. So for me, in my mind, that's my V2 and that's my M2. And it says what molarity, so we don't know what molarity, M1, would that need to be if we only had 2.5 liters of it. So that's my V1. So my M1, I don't know. My V1 is 2.5 liters. My M2 is 1.2 molar potassium nitrate, and my V2 is 10.0 liters. Now, just real briefly here, guys, I chose these guys to be 1 and these guys to be 2. This formula will work if you made these guys V1 and M1 and these guys M2 and V2. That really doesn't matter. The part that matters and the part you need to pay attention to is that this here, these 10 liters, those go with the 1.2 molar. You need to recognize that, right? And you need to recognize that this unknown molarity goes with the 2.5 liters. As long as you've got those grouped together, it doesn't matter if you use them as 1s or 2s. All right, so back to our formula. If I rearrange, my formula becomes M1 is going to be equal to M2 times V2 over V1, because I rearranged, and I put my numbers in, and that's my 1.2 molar times my 10 liters, divide that by my 2.5 liters. Notice the liters cancel because all my units are the same for my M's and my V's, and that means that I need to start with a concentration of 4.8 molar potassium nitrate to be able to make that final solution. Hopefully this was helpful, definitely come to our virtual office hours, Miss Wagner and myself, or email us with any questions, and good luck on the rest of your assignment.